So today we're going to take a look at section 1.2 and part of section 1.3, not the whole thing. So the first thing I'm going to give you is just kind of a general guide for solving problems, not even something specific to math, but just something you can apply to pretty much any process, any problem you're trying to solve. So the first thing is basically reading the problem and understanding what is it that they're giving me and what is it that they want me to find. If you don't understand the information that you're being given, you don't know how to organize that into what's being given and what's being asked, you're not going to be able to solve any problem. So that's the first step. Okay, the second step is to come up with a plan or some type of approach that you're going to use to solve a problem. When we solved the problem that somebody asked me about in the homework, okay, trisecting a line segment, what approach did I use to solve that? What did I do on the board? Yeah?
I made a visual.
I made a visual, yep. I made a visual. So drawing a picture, making a visual, whether that involves a graph or a grid, some kind of visual. What's something else that you might do when you're solving a math problem besides making a visual? And I kind of mentioned this. I said I'm doing it the visual way, but you could also, yeah? Right, you might do something algebraically where you come up with like an equation. Maybe it's an equation that's already known that you can use, like a quadratic formula. Maybe it's an equation you have to figure out. Another method might be making a list. Okay, when would making a list be handy? Well, if I said to you kind of like a probability question, take the letters A, B, C, and I want to know what are the chances if I write down all three letters using each letter one time that I write CAB? What are the chances that I write them exactly in that order? Well, you might make a list of every possible way you could do it. ABC, ACB, BCA, BAC, CAB, CBA. I think I said them all. There's 6 different ways. And then you realize, okay, there's a 1 out of 6 chance that he puts them in the order he just said. Well, you could do it that way. But what might be the downside of making a list? Yeah?
It doesn't scale for larger things.
Yeah, for larger things, that's going to be a pain, right? I said, what are the, let's say instead of just using 3 letters, let's use the whole alphabet. Well, now you might have millions or billions of things in a list, so we don't want to use a list. Okay, so making a list isn't always practical. Page 13's got all kinds of suggestions you can look at. And then the last step is to actually, carry out your plan. All right? So you look at it and you say, okay, they're asking me to solve a quadratic equation. What am I going to use? I'm going to use the quadratic formula. All right, now go ahead and do the math out. To me, usually the last part is the easy part, right? Like if I'm trying to build something or fix something, once I know what I want to do and I have all the tools I need to do it, actually just doing it is pretty easy, but it's all the thought I had to do beforehand to figure out, all right, how am I going to do it? How am I going to build it? Where am I going to put it? What am I going to need? Then once I have everything, now I just do it, right? That's the last step, kind of carrying out your plan. So let's look at this, and we're going to try to implement those steps and see if we can solve it. So this is a problem where a company charges money to rent a car, and they charge you $15 fee up front and 20 cents per mile. So the first thing I want to do is figure out how I'm going to write an equation to represent this. Okay, that's the question. Write an equation to model or represent this situation. First of all, how many variables do you think I'm going to need when I write this equation? Yeah? 3? Okay, what do you think the first variable is going to be?
0.2x and then plus 15.
So when you say variable, let's think about what the variable is going to represent. What is your first variable going to stand for in this problem?
Miles,
Okay, miles. How many miles you drive the car? That is a variable, and we definitely need something for that. All right. In particular, that is the, there's a name for it. We'll get into that. Let's just go through the variables first. So yeah, miles you drive is definitely a variable. And what else is a variable?
Or the car.
What is it?
The car.
The car you pick? Okay, so let's, for this particular situation, let's say that they pick the car and those are the fees for this particular car. So we don't have different pricing options to choose from, we just have this, right? That's what they have to pay for the car that they picked. There is one other thing besides miles.
It would be the total cost.
The total cost. Yeah, so miles and cost. One of those is independent, one of them is dependent. Which is the independent variable? Miles or cost? Yeah?
Miles.
Miles, yes. That's why we would let miles be the x. When you read this situation, you would say that the cost to drive the car depends on how many miles. The cost for the car depends on how many miles you drive it. Cost is dependent on miles. You wouldn't say miles is dependent on cost. That doesn't sound right. It doesn't really make sense. Right? So if you went to this company and you said, "What's my bill going to be?" They would say, "Well, it depends. It depends on how many miles you drive." Right? So the cost depends on miles. So cost is dependent. Miles is independent. So let's see if we can write an equation now. Anyone think they could give me an equation using those two letters and the information up above that represents what's going on? Yep, Nick.
Y equals 0.20x plus 115.
Yep. So y equals 0.20x plus 15. And that's it. That's an equation, slope-intercept form in this case. But it is an equation that represents the cost to drive the car depending on how many miles you go. Any question on how we came up with that? Okay. So now, let's use that model to find the cost if we drive 50 miles, and then we'll do the cost for 100 miles. Okay. If I want to find the cost of 50 miles, I'm plugging that in. Where is the 50 getting plugged in? We have to make sure we put it in the right spot. Riley?
Where the x is.
It's the x, remember. X is miles. So we're going to fill in 50 for x. And we get 0.20 times 50 plus 15. 0.2 is the same as a fifth. So 1/5 of 50 is 10 plus 15 is $25. Okay, so that's the cost to drive the car 50 miles. Now, if I double the miles, can I just quickly say, oh, it's double the cost, 50 bucks, I'm all set? No, why not? Why wouldn't double the miles be double the cost?
Because you'd also be multiplying what should be constant.
Right, that 15 is a constant, that doesn't change. So you should not be doubling that part of it. The mileage part of it gets doubled, but not the 15. So 0.2 times 100 plus 15. And that would give me a cost of how much? Yep, $35. Okay, any question on how we found the costs for those different mileages? So that equation that we just wrote is called an algebraic representation of our problem. Okay, if somebody walked in here right now and just looked at the board, they'd have no idea that that's about renting a car and paying 20 cents a mile plus a $15 fee up front. They would just see an equation. Right? So when you abstract all that information from the word problem and just turn it into an equation, that's an algebraic representation. So now, let's use that to figure out how many miles Sarah drove if she paid $50 for renting a car. Okay. What's different about the kind of question I'm asking here versus the two we just did? This question's different. It's not the same type. Yeah, sorry.
You're trying to find the x, not the y.
We're trying to find the x, not the y, correct? Okay, now we're solving for miles. So that means we're plugging in for the y. So let's fill in 50 where the y is. So 50 equals 0.2x plus 15. And this is an algebraic approach we're going to solve. We're going to do it algebraically, and then we're going to do it graphically on the calculator. All right. In this case, I think the algebraic approach is faster. All right, so the reason it's algebraic is because you are now manipulating this to get the variable alone. In the last two problems, you didn't have to. What's my first step to get x by itself here? Yeah? Yeah, let's go ahead, sorry, Annalise.
Subtract 15 from both sides.
Subtract 15 from both sides. So we do that, we get 35 equals 0.2x. And my last step to get x by itself. Yes, Declan.
Divide both sides by 0.2.
Divide both sides by 0.2. And remember, if 0.2 is a fifth, you're dividing by a fifth, which is the same as really multiplying 35 by, yep.
1/5.
Well, you're dividing by a fifth, which is like
Oh,
multiplying
sorry. Yeah, multiplying it by 5.
by 5. So if we multiply 35 times 5, what's 35 times 5? 175. And that's how many miles that Sarah drove the car, 175. Okay, and that was algebraic. Nothing visual, purely an equation. Now, let's do the same thing again, but we're going to do it on the graphing calculator. Okay, so what I'm going to do is I'm going to start by making sure I have my calculator, and then I'm going to turn it on. If there's anything on the screen that you don't want, you can clear it. It doesn't really matter, but I just clear it. And we're going to go to the screen where we can graph something. Okay. What's the button I showed you yesterday that brings you to the screen where you can graph lens? Yep, we're going to go to y equals. Might still be something in there from yesterday. We need to get rid of that. So we're going to clear that up. And everybody should be at a screen that looks exactly like that. Is anybody not at that screen? All right. So the way that we're going to do this graphically is we're going to look at each side of the equation separate. We've got this, and we've got that. We've got two separate things. We are going to put what's on the left side in y1. So we're just going to put in the number 50. I'm going to press the down arrow. And we're going to put what's on the right side in y2. Okay, so we're putting each side of the equation in y1 and y2. It doesn't matter if you type 0.2x or 0.2x, it's the same number. And remember, we talked about how to do x yesterday. That's the button right below mode. Okay. Does everybody have something that looks like that? Okay. So what's the name of the zoom that we can start out with? We talked about this yesterday. It's just kind of a starting point for our picture. Yeah?
What's the standard?
Yeah, standard. So we can do zoom and we can do 6. And while that little yellow circle is spinning in the upper right, it's doing something. Let's wait till it stops. Okay, it's done. Okay, so what's going on? We don't see anything. How come we don't see anything? Yep.
It's outside the view.
Right, it's outside the view. So now we don't just want to start guessing, well, what should I try for my window? Right? We need to look at what we graphed and think about it. What is this? 0.2x plus 15. That's something from Algebra 1. Like what's the shape of that? Yeah.
Linear.
It's linear. Okay. Can you tell me more about the 0.2 and the 15? What does that mean? Yeah.
15 is where it starts on the y, and it goes up 0.2 for every x.
Okay, so yeah, the point 15 is my y-intercept. What's the highest my y-axis is going on the standard window? Yeah,
10.
it's only going to 10. Okay, if I don't have something starting till 15, you're not going to see it if you only look till 10. Okay? So we definitely got to go higher than 10. And what about this? That's a little bit simpler than the right side. That's just like y equals 50. What kind of graph is y equals 50? Yeah.
Horizontal.
A horizontal? Yeah, it's a horizontal line at what number?
0.
At 0?
-50.
At y equals 50, right? It's a horizontal line at 50. Well, you're definitely not looking to 50. So I would set the y max higher than 50. I don't set it exactly at 50 because then it's going to be on the edge of the screen. Let's set the y max to like, I don't know, 60. And now let's just hit graph. So again, that was in window. Let's just hit graph and see if we've got something. Okay, we've got something. Okay, so that's what we got right now. Now, I'm trying to find out where y1 equals y2. What do you think that means? Not algebraically, we did it algebraically. What do you think that means visually? Where y1 equals y2. This is y1, this is y2. Yep.
Where they intersect.
Where they intersect. Yep. Well, I can't see where they intersect, so I'm not going to be able to figure that out. I have to adjust something. What do you think I need to adjust? There's 4 values, y min, y max. We already adjusted the y max. And x min, x max. Lens?
Would it be X max?
Yeah, we need to adjust the x max. In fact, we already know what we need to adjust it to. We know it has to go all the way to 175. Okay. So if we didn't know that, we might just have to take a guess. But we know. I'm going to go a little bit past it, so it's not on the edge of the screen. Hit graph. And now, I can definitely see, it's close to the edge, but it's not on the edge. I can definitely see where they cross. Any question getting this picture? Now, we've got the picture, but how do we figure out where they cross? Well, you can press trace, and you could kind of move your cursor until you think you're close, and then read what it says, down here. That looks pretty close. Or there's a way we can calculate it exactly. Right? So instead of using trace, which is not accurate, because we know the answer is 175, but pressing trace, I can't even get to that. It kind of jumps over it. Just the way the calculator works. So what we're going to do is something a little different. We're going to press second. Okay, so that's the button in the upper left. And you're going to press trace. Okay, second trace brings you to the calculate menu. So you should see this. Okay, we're going to use options 2, 3, 4, and 5 this year. 6 and 7 are calculus. And option 1, we have better ways to do it than this. So 2, 3, 4, and 5. Today is option 5. I'm going to calculate where they intersect. So press 5. Everybody should be at a screen now that says first curve. I'm just going to stop there for a second. Is everybody at a screen that says that? Okay. When you want to find an intersect, it's going to ask you 3 questions. The first thing it's going to say is pick a point anywhere on the first thing that you're trying to find where it crosses the other thing. It doesn't matter where. You can pick a point anywhere on that blue line, but you have to hit enter. Okay, so now the calculator knows, all right, blue line, and what's the other one? Well, we want to tell it to use the red line. So you can pick a point anywhere on the red line. It doesn't matter. And then you have to hit enter. Now you might think, why do you need to tell it the blue line and the red line? Well, maybe you have a blue line, a red line, a black line, a green line, a yellow line. You got 6 or 7 of them. You're going to tell the calculator which 2 you want to use. In our case, we only have 2. So now we should be at a point where it says guess. Does everybody see the word guess on their screen? Okay. The guess doesn't really matter in this case. I'll let you know when it does. You can put it close. You don't have to put it close. You basically can just hit enter. And when you do that, it will tell you that the answer is when x is 175, which is what we got algebraically. Okay. Any questions on how I just found an intersection between those 2 points? And if you forget, it'll be in the video. You can go back and just, my suggestion is if you forget something, write down the time, or you could just write down, oh, that was 20 minutes into the video that he did that, and then you can fast forward and find what you need. All right, so no questions on that. Okay, so that is finding an intersect. Now, this particular window that I have right there, that's a good window. I can see everything I need to see. The main thing is where they cross. If you have a window that shows everything you need to see, that is called a complete graph. So a lot of times in the homework, they're going to say, find a complete graph, or find a complete window for the following. That basically means find a window that shows everything that's important. What's important? Well, it depends on the problem. If I had a parabola, I would say the vertex is important. Where's the bottom, or where's the high point? Okay. If I had 2 lines and I'm looking for where they cross, the intersection point is important. If I do zoom 6, that's an awful window for this problem. I can't see anything. That is not a complete window or a complete graph. So all you have to do to find a complete graph is write down the window. So you basically would write down x min, x max, y min, y max. And there isn't always one right answer for the window. Like I think I set my x max to maybe 190. I don't remember, somewhere around there. If you did 200, that would have been fine. 220. If you did like 50,000, no, because then that would probably be so far it would squish the graph. It wouldn't look good anymore. But those are the 4 things you need to write down if it asks you for a window. This one I think we already did yesterday. Did we graph this one in class yesterday? The parabola x squared plus 10. We did that? Yeah. So it's just another exercise where the parabola is off the standard window and you have to zoom higher to see it. Okay, so I'm not going to go through that one again. But I will mention this. That particular curve is called a parabola. So if you don't know, if you didn't know that the graph of a quadratic is a parabola, I would write that down. That's kind of a simplified quadratic. There's not a lot to it. In general, a quadratic could be a little more complicated. You could have this term in the middle, which this one does not have, but that's still a parabola. It's a little more complicated one. And that's called the general form of a quadratic equation. It's generally the form that you see like if you're going to be factoring something, like 2x squared plus 4x plus 7. Right? It's the format you would see when you're getting ready to factor. All right, let's try graphing this one. Square root of x plus 20. Let's find a complete graph. So the first thing I need to do, I'm graphing something new, get rid of the old. Okay, so where is square root? Well, it's the button you used for squaring, except you press second. So press second, and then press the fifth button down on the left side. You should get a square root button symbol just like that. We're going to put in x plus 20. Now remember, the biggest category of numbers we talked about yesterday was real numbers. Depending on what you plug in for x, we could go outside the real number system. We don't want to do that. If we want to stay in the real number system, we can only take the square root of what kind of numbers? We don't want to end up with imaginaries. Yep.
Positive.
That's a lot of them. There's one more you can take the square root of that's not positive. What else? Yep.
0.
0. So in other words, we don't want a negative. Okay? We want the number to be 0 or higher. If we want this to always come out 0 or higher, what does that mean you would be allowed to use for x? I always want what's underneath here. I want the radicand to come out 0 or higher. So what does that mean I could fill in here to guarantee that that happens? Yep. Negative 20. Just the number negative 20?
Sure.
How about negative 19?
Yeah.
What about negative 18?
Negative 20 and up.
Negative 20 and up. So x can be any number greater than or equal to negative 20. Or in set notation, any number from negative 20, including negative 20, as high as you want to go, but we can never reach infinity. Okay, we're going to learn more about set notation. I just keep trying to throw it in there so you're getting used to seeing it. But we're going to talk a lot more about it formally. So now, this one we can graph, but we had to think a little bit about the domain. Let's say we try to go beyond negative 20. Let's set our window to negative 30 and see what happens. So let's go as low as negative 30. And we can leave everything else the same. Okay, just put your x min at negative 30. There's no graph. If you try to go past negative 20, the graph doesn't go past negative 20. Right? It starts at negative 20, and it goes up to the right forever. And that's what a typical square root function looks like. It's basically half of a parabola on its side. In fact, if I drew the bottom part, you don't have to worry about what I'm doing. I'm just typing in the opposite of square root of x plus 20. I would get the other side of my parabola. Okay, so that's exactly what a square root is, half a parabola. Okay, so any question on the window for this one? This would not be a good window. A square root function always has a starting point. I can't see the starting point here. In fact, to me, that blue line almost looks like a straight line. I can't even tell it's curved. That's not a great window. Sorry. The one that went to negative 30 was much better. You could probably do negative 20. The only thing I don't like about doing that is it's going to be right on the edge of the screen. And then, we wonder, does it go a little bit past that or not? So if you do negative 25, something like that, you're safe. Okay. Right, let me show you how you can type in some data points. Okay, so this isn't a graph. This is more like a scatter plot. We're just graphing some dots. So let's keep this on the screen and see if we can type in these points. Well, the first thing I'm going to do is I already have a graph there. I'm going to get rid of that. because I don't want to see that. Graphing data points is totally different than graphing an equation. We're just going to literally graph 7 dots, or however many I've got there. So, first thing it says to do is press Stat, and then go to Edit. Stat is the button right below Delete. It's in the second row from the top, all the way on the right-hand side. Stat. Has everyone had a screen that looks like that? Okay. Next thing it says is go to Edit. Well, I'm already on Edit, so I'm just going to hit Enter. Now, I don't have anything typed in, but you might. Let's say that there's numbers already typed in like that. To get rid of those numbers, highlight the number, not L1. If you highlight L1 and do what I'm about to tell you, then we're going to have to reset the calculator. Okay. So highlight the number you want to get rid of, and then just press Delete. If I had a number in a different list, I could use my arrow and go to that list and delete numbers. So I want to make sure everybody's at a screen that looks just like that. Anybody not at that screen? Okay. Now, we're going to type all the X's in L1. L1 just stands for the first list. So you're going to do it like this. -3. Another important point, make sure for the negative button, you use the button below the 3. That's the negative button. The minus sign on the right-hand side is to do a subtraction problem. That's not a negative sign. That's different. Okay. So -2, -1, I'm just hitting Enter each time. It's easier to do all the X's first because when you hit Enter, it just goes down. -3, -2, -1, 0, 1, 2, 3. All right, so you should have all your X's in L1. And we're going to put the Y's in L2. So if you press the right arrow, that will bring you over to the next list. And now just start entering the other numbers. Double check, make sure we look good. And now you should have something that looks just like what I have. Okay. Any problems getting the numbers typed in? Okay. So everything is saved. You don't have to save it. It automatically saves as you go. So we're done with that. So we can quit. Go back to the main screen. To quit, you press second, and then the mode button at the top. It says quit. Okay, everything's there. If you made a mistake and you had to go back in, you can do the first step all over again, and you'll see your numbers are still there. Okay, so the last step, the last 2 steps, is we want to graph those points. But we have to tell the calculator to do that. I want you to press the Y equals button. And then I want you to hit the up arrow. When you hit the up arrow, it should highlight plot 1. It should be blinking. Is everybody's plot 1 blinking? Okay. Hit Enter. What's going to happen now is plot 1 is selected. If you hit the down arrow, you'll be able to see that. We just turned on a scatter plot. Now, just like a graph, we need to check our window. What was the, let's press window. What was the smallest X value that we typed in with all those points? Yeah.
-3.
-3. So let's do -5. Go a little past it. What was the biggest x value we typed in? Yeah, that's
3.
3. All right, I'm going to do 5. How about the smallest y value? We went lower than -10. That's no good. Yeah,
-18.
-18. So let's do -20, and the biggest one was +20. Okay. Does everybody have that typed in for the window? Now, before we hit graph, these should already be all set, but I just want to check something on everybody's. Press second, and press y equals. We already did this, but everyone's plot 1 should say on. Yep.
I think you come back with syntax error.
And you use that for the negative sign
Yeah.
for the numbers? Let me take a quick look.
Sure, if I'm trying to do the window, it just keeps coming
No,
back.
you use the minus. So for negative, you gotta use that, which is so the difference. I know it's a small difference, but you have the big one, you have the small one. Does that make sense?
Yeah.
Okay, so plot 1, everybody says on. Yep.
Mine's stuck on the stat thing, like the list.
On the list,
Yeah.
so you pressed,
The
So-
stat enter.
did you put all those numbers in?
No.
No, so you have to delete all those. Oh, did you freeze? Let's see. What's that? Okay, I had to reset it, but it's gonna work now.
I'm just gonna line instead of the dot.
That's okay.
Okay.
If it's a line, that's okay. So mine's gonna do dots, someone else's is gonna connect the dots. I don't really care about that. I could change it if I wanted to. Like I could go into the settings and adjust it, but I'm not super worried about, I can make a bar graph, I could do all kinds of things. But everyone's plot 1 says on, and does it say L1 and L2 right below it? Okay. If it didn't say L1 and L2, we'd have to fix that, but it shouldn't unless you or someone before you changed something that I didn't say to change. Okay, so we checked that. We put our window in, we put our points in. Let's hit graph. You should see something that looks just like that. And that's it. That's how you can graph a scatter plot. Now, the nice thing about doing something like that is, let's say that they wanted me to figure out a curve or figure out an equation that goes through all those points. Well, I can do that, or the calculator can do it automatically. And in Y1, I could do a graph. Give me 1 second. Don't worry about what I'm doing. I'm just trying to show you that the calculator can figure out an equation that goes through all those points perfectly. All right. So now what could that be used for? I could make a prediction. Maybe when x is 2.5, predict to me what the y value would be, and I can do that with my formula now. So that's the advantage of graphing points on a calculator. It can find equations for you. But for now, I just wanted to show you how to graph points. Okay. So to get it ready for the next person, let's go back to stat. Let me try this before you do it and make sure that it works okay. I'd rather mess up my calculator than have to help everybody fix it. Yeah, that's fine. All right. So we're going to press stat, and we're going to clear the list. So if you press 4, that'll clear the list. And I just need to tell it what list to clear. I think you can do both at the same time. Does everybody have clear list on the screen? Press second and press 1. And then don't hit enter. Let's try putting a comma. So comma is right below the sign button and above the 7. And let's do second 2. So we're going to try to clear L1 and L2 at the same time. I don't know if that's going to work, but I think it will. And it should say done. If you go back to stat and you go to edit, there shouldn't be anything there anymore. You can delete each number one at a time too, but if you had a list of 600 numbers, doing this is much faster to clear the whole thing. Okay, any question on that? Again, it's not something we do a lot, but we are going to graph points like a scatter plot at some point, and that comes in real handy. All right, so that's it for the bulk of the calculator stuff. So we're going to finish up with a little bit of review, again, like we did yesterday from Algebra 1. So I started using some words, independent, dependent. Okay? There's some terms that we use when we're describing the x variable and the y variable. There's a few different terms. You can call the x the independent and the y the dependent. You can also call them domain and range. We are going to talk a ton about domain and range. Domain is basically what you're allowed to fill in for the x. Range is the answer you get back. And you might think, well, couldn't you plug in anything you want here? Well, algebraically, yes. Practically, no, because x stood for mileage. So plugging in a negative amount of miles wouldn't make sense. Even though you could, and you'd get a numerical answer. It wouldn't make practical sense. Input, output, so just different names for the x and the y variables. Now, this particular graph is a function. Does anybody remember there's a test, the name of a test you can do? It's kind of a visual thing to see if a picture is a function. Yep.
The vertical line test.
Yeah, you can do what's called the vertical line test. And what the vertical line test basically does is visually check for that. It checks to make sure that every x value has exactly one y value. That's what the vertical line test does. It makes sure that every input value has exactly one output value. The vertical line test is not a formal way to define a function, though. This is a formal way to define it. Every value of the independent variable has exactly one value in the dependent variable. Just kind of further explaining domain and range. I already said this. Again, domain is what you're allowed to plug in. Range is the answer you get back. Now, some functions you can't plug in anything you want. There are two functions we're going to study this year that you have to be careful with. Square roots and fractions with variables in the bottom. There is a number you cannot plug in for x in that. If you do, we're going to have an issue with the formula. Right. What number would you not be allowed to fill in for x right there? Yep, 2. So the domain of that problem is everything except 2. You can plug in 1, plug in 0, you can plug in negative 8.5, but you cannot plug in 2 because you would divide by 0. So we have to watch out when we talk about these kinds of functions and those kinds of functions. If we're dealing with real numbers, we would not want to plug in something like 1 for x. 1 minus 2 is a negative number. We're not talking about square roots of negatives right now. Okay, so those are the two main functions we have to watch out for with domain. I just said that to you. You're dealing with real numbers right now, not imaginary. There's two different notations for functions. I've been using this y equals notation, but you can also use this. Someone remind me how you pronounce that? Yeah?
F of x.
F of x, yep. So that's f of x notation. We'll use that quite a bit when we're talking about functions. All right, so let's try this one. We already graphed one pretty similar to it, but this is the square root of x minus 3. Can anybody tell me what kind of numbers I could fill in for x to make sure I stay in the real number system? You couldn't plug in 0. 0 minus 3 is a negative number. You could plug in this number or basically higher. Yep.
3 or above?
3 or above. That is the domain for this problem. If you weren't sure, you can go to y equals. Now, the scatter plot is still turned on. We can turn it off. There's nothing in there for data anymore, so it's actually not going to do anything. But I'm still going to press the up arrow and press enter just to turn the scatter plot off. Even though there's no data, let's just shut it off. So let's type in the square root of x minus 3. Okay, and Emma just told us that the domain is any number from 3 and up. So I'm going to go to my window. I could leave it at -5. That's fine. I want to make sure that it's, at least I can see 3, and I went past it. I'd like my x max a little higher, though. Let's put it back at 10. Let's hit graph and see what we have for a picture. It's okay. I can't see the curve that well. If I want to see the curve better, I could set this a little bit higher. Now I think you see more of it. You can definitely see it's curving. So the farthest left that this goes is 3, but it goes to the right forever. That is your domain. Every number from 3 and up. Now the range is how high and low it goes. What does it look like the lowest that graph goes is? Yep.
0.
0. Yep. The lowest it goes is 0. And what's the highest that it's going to go? Yep. Infinite. You might say, well, yeah, it looks like it only goes to 3 or 4. Well, I mean, if you could zoom out forever, right? It's just going to slowly keep going up. So the range is every number from 0 and up. How would you write that as an inequality? Lennox?
Would it be y is greater than or equal to 0?
Yep, perfect. Y is greater than or equal to 0. So domain, we usually figure that out by hand. Range, a lot of times we'll graph it, look at the picture, and look at how high and low the picture is. Because range can be harder to figure out. But domain, that's a little bit easier. Let's try this one. Square root of x squared minus 4. Clear that. Put in x squared minus 4. Now, for the domain, are there any square roots in this problem? What do you think, Evan? No, there's no square root symbol there, so we don't have to worry about square roots of negatives. Are there any fractions in this problem with the variable in the bottom? What do you think, Marcelo?
No.
No. So the two things that I told you that could be a problem for the domain are not in this problem. So what do you think that means the domain is? Yeah. All real numbers. You can take any number you want and raise it to the second power. You'll never have an issue for that. So the domain is all real numbers. Once we type that in, let's do zoom 6. That'll just reset our window. Is the range all real numbers? you think? No? Well, Emma, what do you think the range is?
Y is greater than or equal to -4?
Yes, it's every number from -4, and it'll go up forever. Yep. Perfect. Now, another function we didn't talk about is absolute value. I'm not going to do a full example, but I just want to show you where the absolute value button is in case you need it. So to get to absolute value, you press Math, press the right arrow to go to number, and the first option is ABS. That's absolute value. So Math, press the right arrow, and it's the first option that you will see. So now I could type in something like, I could type in the same thing. Absolute value, it's going to start looking the same, but notice how it changed it a little bit. Because remember, with absolute value, you can't go negative. So it takes that negative part and flips it up to be positive. So that would change, not the domain, but it would change the range to be 0 and up of the red one. It would not be -4 anymore. But the point here was just to show you where absolute value was. Yes, evaluating. So if they ask you to evaluate a function, it basically means take the number or letter they give you and fill it in for the variable. That's what evaluate means. Take the number that they give you and fill it in for the variable. And they'll give you a formula that they want you to plug it into. So let's try f of -2. Okay, I'll go through the first one. In this formula, everywhere you see an x, change the x to a -2. So that's what it means to find f of -2. What's that going to come out to? Yep. 5. Yep. That's it. It's just evaluating a function. Let's plug in 3. What's that one going to come out to? 10. And the last one they want me to plug in is a. Replace the variable with an a. All right. What's that come out to? Thoughts on what I do with that from here? How about G? Any thoughts what we do?
Square root.
No, there's no square root in there, so we don't want to just throw a square root in there. There's nothing with a square root. Yeah?
Is that it?
That's it. You're done. You replace the variable. That's all it says to do. Replace the value they give you, plug that into the formula, and simplify it as much as you can. That's it. You can't simplify a squared plus 1 anymore. Okay, so not all equations are functions. For example, if I take this one, and let's say I want to graph that on the calculator. Well, I can't graph y squared equals x. The calculator can only graph when you have a y alone, not a y squared. So if I want to graph this, I need to isolate the y, which means get rid of that. How do we get rid of squaring? We square root. When you square root both sides, you have to remember that when you take a square root, there's a positive and there's a negative. So if I said, like, what's the square root of 4? A lot of people say 2. Don't forget -2. That's not a function. If you graph the square root of x and you graph the negative square root of x, which is how you have to type that in on two separate lines, look at what happens. There's half of your parabola, and there's the other half. Okay. That fails the definition of a function. If I pick an input value of, let's say, 9, I could be here at 3. I think it's about 3. Or I could be at -3. That is not a function. So for the input value of 3, there are two different of 9, there are two different output values. 3, -3. That fails the vertical line test. Okay, so the vertical line test is a very simple visual way to determine if something is a function. If you can draw a vertical line and it hits the graph more than once, you do not have a function. There you go. Fails the vertical line test. Okay, circle. That would fail the vertical line test. How about something like this? Would that pass the vertical line test or fail? Yeah, that'd pass. It fails the horizontal line test. We'll talk about that later. But it passes the vertical line test, no problem. Okay. All right. Any questions on that? All right, so we did one section and we did half of another section. So the homework tonight's on 2 different pages, but I think I took those 2 pages and I combined them into the same folder on Schoolage Book. So you'll find all the homework pages you need together. Okay, so the first page, that's on 1.2. That's what we did on basically calculating an intersect and modeling a car problem. And then page 30, that was the review from Algebra 1, evaluating function, domain, range, things like that. Okay, so we will go over that homework next time we have class, which will be on Monday. So remember, it's double A week to start.
Tuesday.
Tuesday, yeah, because Labor Day is Monday, so that'll be for Tuesday.